Welcome back to today's session. We'll deal with a few more problems on series and sequences and how we would go about analyzing their convergence. Right. So that would be the main sort of theme of our session today, right? So there's a few questions here, and feel free to stop at any point during the video so you can attempt the problems before you actually see how we go about solving them, right? So let's start. We have the first question that is giving us series. It's giving us a series is n is equal to 1 to infinity of x minus 4 to the n. And we are basically asked to find the sum of the series, right? And we are given multiple options here and we have to choose the correct one. So since the series is a convergence, is a geometric series, then we know that geometric series are of the general form, once again, a times r k. K is going from 1 to infinity. And the way we check if the series is converging is our absolute value of r has to be less than 1. And the sum is given as a over 1 minus r, with a being the first term, right? So first term of the series. Okay, so um, let's do that. So the first thing that we note here is that they've already told us that the series is converging, right? What is that? So that means that we know intuitively that r has to be less than 1 because they've already told us that the series is converging. And looking at our problem, r is just equal to x minus 4. So the absolute value of x minus 4, we know it's less than 1. Okay, so that means that negative 1 is less than x minus 4, which is less than 1, right? These two expressions are equivalent. Okay, so now that we know that, we can add 4 on both sides. If you add 4 on both sides, then you have 3 is less than x, which is less than 5. Okay, so this is the sort of the radius of the total sort of interval of the values of x under which the convergence is assured. So the series converges only when x is between 3 and 5, in other words. So that means that our sum now is equal to a over 1 minus r, which is just a is our first term, n is equal to 1. So our first, when n is equal to 1, our first term gives us x minus 4 divided by 1 minus x minus 4, which is our r, which is x minus 4 divided by 5 minus x. Okay, so that is our sum. So our sum is x minus 4 over 5 minus x when x is between 3 and 5. Right, so that if we look at the options here, it's not 1, it's not 3, it's 2. Right, because all the other options are eliminated as well. So the correct answer here is 2. Now, moving on to the second problem. Once again, we are given a series as n goes from 1 to infinity of 4 plus n squared over n cubed. And we are asked to use the comparison test to check which one of the statements that's given to us is true. So with the comparison test, you know that you have to find another series, right? And you just have to check the convergence of that series to confirm whether or not the series that's given to us here is converging, right? So for that case, we'll just choose the series as n goes to from 1 to infinity of n squared over n cubed, right? Which is just the same as the series from n is equal to 1 to infinity of 1 over n, which, if you remember, this is a p-series. A p-series, but more specifically a harmonic series, right? And you know that the characteristic of harmonic series is they diverge. So immediately, since this series diverge, we can immediately conclude that the original series that's given to us by comparison test is also diverging, because the p series, we have the p series where p is equal to 1. So that's the correct option here. All the other ones are eliminated. Okay, so if you think about it a little bit more, it might make more sense. You just revise the concept of comparison test, and this should be more. This should make more sense to you. Right. So moving on to the next question, we are given a series, and we are asked to use the ratio test to confirm one of the given statements. So the ratio test. So first we are given an, which is 10 to the n divided by n plus 1 times 4 to the 2n plus 1. Meaning that a of n plus 1 is just 10 to the n plus 1 divided by n plus 2, times 4 to the 2n plus 2 plus 1. And using the ratio test, we therefore have to take the limit as n tends to infinity of a of n plus 1 divided by a of n, which is equal to the limit as n tends to infinity of 10 to the n plus 1 divided by n plus 2 times 4 to the 2n plus 3 multiplied by the inverse of a of n, which is just n plus 1 times 4 to the 2n plus 1 divided by 10 to the n. Now, let's simplify where we can. 10 to the n will simplify with that. 4 to the 2n will simplify with 4 to the 2n there to leave us with limits as n tends to infinity of n plus 1 times 4 times 10 divided by n plus 2 times 4 cubed times 1 basically. And we can simplify even further the 4 and the 4 cubed. We have, and take out all the constants. Then we have 10 over 4 squared, which is 16, multiplied by the limit as n tends to infinity of n plus 1 divided by n plus 2. Now, if we divide by n on both numerator and denominator, what do we get? Well, we get 10 over 16 times the limit as n tends to infinity of 1 plus 1 over n divided by 1 plus 2 over n, which therefore gives us that this limit is equal to 1, so this just 10 over 16. This is just 5 over 8. And this is less than 1, which tells us that our series converges. Okay. Right. So now that's the correct answer there. So because that's our limit, and our limit is just basically p here. So this limit is often referred to as p, as you'll see in the options that are given there. So we know that our series converges. So all the options that tell us that the series diverge are eliminated. So we have two options. P is less than 1 and P is greater than 1. So we know that P is less than 1, as we found here. So option 5 is out. Option 1 is the correct one. Okay, so hopefully this makes sense. Now, moving on to the next question. We are given a series from n is equal to 1 to infinity of 3n over 8n plus 1 to the n, right? And we are asked to use the root test and check which of the following tests is correct. And the root test just tells us we have to take the square roots, well, not the square root, but rather the nth root of the series, and then take the limit of that. So you have to find p such that it's the limit as n tends to infinity of the nth root of the series, 3n over 8n plus 1 to the n, which is just the limit as n tends to infinity of 3n over 8n plus 1. Okay, which if we divide by n on numerator and denominator, we have limit as n tends to infinity of 3 over 8 plus 1 over n, which if we substitute in the value of n now, we have leaves us with 3 over 8, which is our limit, which is less than 1, which means that our series converges. Okay, so we know that our series converges, so all the options that tell us that our series diverge are eliminated. So we are left with two options, and the correct option here then becomes option number 5. So this is the correct answer here. And just to note, something that should be quite clear is we are taking the square root here of positive terms, because as you can see from the series, all the terms given in the series will be positive. There won't be any negative term, because n will only be increasing, right, to positive, higher and higher positive values. So the overall series will only have positive terms. And that just means that we are not at the risk of having a negative value under the square root. So therefore, we are safe by taking the nth root of the series. Right. So that's that. Moving on now to the next problem. Here we are asked to find the radius and the interval of convergence of the series that's given to us, which is as n, the sum as n is equal to 1 to infinity of -1 to the k minus 1 times x to the k over square root of n of k. So we'll call this our U of k. And we'll be using the ratio test to find our interval of convergence, right? So our U of k plus 1 will therefore be -1 to the k plus 1 minus 1 times x to the k plus 1 divided by root of k plus 1. Now to find our p, which is our limit, as k tends to infinity, of absolute value of k plus 1, u of k plus 1 over u of k, we have this limit being equal to the limit as k tends to infinity of the absolute value of what? U of k plus 1 is just -1 to the k times x to the k plus 1 divided by root of k plus 1 multiplied by the inverse of u of k, which is root of k divided by -1 to the k minus 1 times x to the k, and the absolute value. We can simplify -1 to the k as well as x to the k to be left with the limit as k tends to infinity of x times root of k divided by root of k plus 1 multiplied by -1 to the -1, which -1 to the -1 is just 1 over -1, which is -1, and under this, the absolute value, -1 just becomes 1, so we can omit it. And we can also take x out because it's a constant that's not affected by the value of k. So the absolute value of k we have the absolute value of k multiplied by the limit as k tends to infinity of root of k divided by root of k plus 1, which we can divide by k, root of k in the numerator and denominator to get the limit. Sorry, forgot. Absolute value of k times the limit as k tends to infinity of 1 divided by root of 1 plus 1 over k, all under the square root sign here. And if you substitute the value of k, you'll see that this limit will give you 1, which means that we'll be left with absolute value of 1 of x times 1, which is just equal to the absolute value of x. And we know that the rule for the convergence here is that p has to be less than 1, meaning that the absolute value of x has to be less than 1, meaning that x has to be between -1 and 1. So that is our interval of convergence. So now, our general interval of convergence. Now we need to find the radius. What's our radius of convergence? Well, we know that for this series to converge, x has to be in between -1 and 1, but we don't know what happens at the extremities. So what happens when x is equal to 1 and x is equal to -1, right? We don't know. So let's investigate what happens there. So at x is equal to 1, right? Our series, right? Our series become what? What does it become when x is equal to 1? Well, we have the sum from k is equal to 1 to infinity of -1 to the k minus 1 divided by root of k, right? Because 1 to the k is just 1. So that's what our series is. And when we have that, by taking our limits of this, by taking our limits test of the series, what do we find? We find that the limit as k tends to infinity of this series, which is -1 to the k minus 1 over root of k, what happens is that this tends to 0, which tells us that our series converges. Okay, because the limit exists. So now what happens at x is equal to -1? At x is equal to -1, our series therefore becomes the sum from k is equal to 1 to infinity of -1 to the k plus minus 1 times -1 to the k divided by root of k, which we can simplify further to be the sum as k goes from 1 to infinity of -1 to the 2k minus 1 divided by root of k. And that tells us that first of all, what that tells us is that the -1, right? So we can rewrite this as the sum from k is equal to 1 infinity of -1 to the 2k multiplied by -1 all divided by to the -1 all divided by root of k. So this first term here, the first factor here, -1 to the 2k, we know that that will always be +1 because whatever the value of k is, -1 to the 2k will always be a +1. So it doesn't change, right? It doesn't alternate sign. We can just eliminate it out of our series, right? So we are left therefore with the sum as k is equal to 1 to infinity of -1 to the -1, which is just 1 over -1, which is -1. So we have -1 divided by roots of k. We can take out the negative. We are left with the sum from k is equal to 1 to infinity of 1 over root of k, which once again is a p-series. But it's a p-series with p equal to 1 over 2, which if you look at the rules, that means that this series diverges when p is less than 1. Okay, that's the rule for these p-series. And what that means is that at x is equal to -1, our series diverges. So we can't include it in the radius of our um, of our convergence. So the overall interval of convergence is therefore the interval from -1 to less than kx, which is less or equal to 1, because we know that when x is equal to 1, it works out, the series converges. But when x is equal to -1, it doesn't, which is why we exclude -1. And our radius of convergence is therefore 1, because we are moving from x is equal to 1 to 1. From x is equal to, in the middle here, 0 to 1, because you know that from -1 to -2, that's 2, that's a unit of 2. So in between, x is equal to 0, that's a unit of 1. So our radius of convergence is 1. because it's going from x is equal to 0 to 1 in either directions, with 1 being included, but -1 being excluded. So our radius is 1. Hopefully this makes sense. Right, and that's it for all the problems that we had to look at. Thank you so much for joining. You are free to stop at any time along the video to attempt the problems on your own before you look at the solution. And if you still have problems, feel free to drop me a message, and I'll comment below the video, and I'll try to address the problems as much as I can. Right, so thank you so much for joining. I'll see you guys in the next one. Thank you. Bye.